So we're going to start off covering terminating and repeating decimals. So terminating decimals are decimals that stop and don't go on forever in a pattern. And so you can add zeros to the end of these types of decimals and it won't change their value. Repeating decimals, on the other hand, you can't just add zeros to the end of them. They repeat forever in a pattern of digits. And we use a bar or a line to show the pattern of numbers that go on forever. So you can see in that first decimal, it repeats forever in threes, so we use a bar over the 3. In the second decimal, we can see it repeats forever in 6 fives, so we put a bar over the 6 5 to let them know that that pattern of digits goes on forever. So that's the difference between terminating and repeating decimals. So we're going to take a deep dive into dividing decimals. So there's two types of situations you're going to have to look out for when you divide decimals. We're going to look at the situation where there's a whole number on the outside. And we're also going to look at the situation, there's a decimal on the outside, and you have to handle that situation slightly differently. I want you to take a focus on the top left corner here. See how that division looks like it goes into long division? I want you to keep in mind that the first car always goes into the garage. In other words, the first number in any division problem always goes inside for the long division, even if it's the smaller number. So just keep that in mind as we work through these examples. So let's look at the first situation when you're dividing by a whole number. So when you're doing division and the number on the outside is a whole number, you can go ahead and do the division. All right. So what you see here is 3,872 divided by 4. It's just normal long division. You just get 968. Now when you do decimals, it works the exact same way. First, you need to check and make sure that the number on the outside is a whole number, and it is. So it's okay. So all you do is just take that decimal point on the inside, push it upward, and then you just do the normal long division. And the final answer will be 9.68. And you can see how the long division works exactly as if there were no decimal point in the first place. All right? So when you divide decimals, the goal is to get a remainder of 0 at the end. And so if you do not get a remainder of 0 at the end, you have to keep adding zeros until you get a remainder of 0. So let's look at this example. So the first thing we need to do is check and make sure that the outside is a whole number, and it is. So now we can do the long division. Doing the long division, we end up with the remainder of 2. The remainder is not 0, so we have to add a 0 and keep going. So adding the 0 and doing the division again, we end up with a remainder of 4. The remainder is not 0, so you have to add another 0 and keep going. Now that we've added another 0, now we have a remainder of 0. The problem is done, and the final answer will be 0.625. So when you do your division, try not to leave gaps in your decimals. If you see a gap, just fill it in with a 0. Let's look at this problem. So first thing we're going to do is we're going to set it up, and as you can see, there's a whole number on the outside. It's okay. We can go with the division. So 20 can't go into 14, but it can definitely go into 148, and it goes into it 7 times. Notice how there's a gap between the decimal point and the 7. We're just going to go ahead and fill that in with a 0, and now we can proceed with the division. Working through the division, you're going to end up with a remainder of 8. The remainder is not 0, so you're going to have to add a 0 and keep going. Adding that extra 0, now we have a remainder of 0. The problem is now done, and the final answer will be 0.074. So the goal is to get a remainder of 0. But sometimes when you do this long division, you'll see that you'll never get a remainder of 0. The remainders will start to repeat. And when that happens, you can stop the division and write the answer as a repeating decimal. So the first thing we need to make sure is that the outside is a whole number. And it is. So we can go ahead with the division. Moving along with the division, we end up with the remainder of 2. The remainder is not 0, so we have to add a 0 and keep going. Moving forward, the remainder is still not 0. It's 2, so we'll add a 0 and keep going. We get a remainder of 2 again. So no matter how many times I do this problem, the remainders are going to keep repeating. I'm going to go ahead and stop the division, and the answer is going to be a repeating decimal. You look at the very top, we can see that it looks like the sixes are going to go on forever. So the answer is going to be 0.86 with the 6 repeating, and we'll put a bar on top. All right, let's look at this example. So once again, we check and make sure that there's a whole number on the outside, and it is. So let's proceed with the division. Working out the long division, we don't end up with a remainder of 0, so we add a 0 and keep going. Working it out, we still don't get a remainder of 0. We're going to add a 0, drop it down, and keep going. Once again, we still don't get a remainder of 0. We're going to add another 0, drop it down, keep going. We still don't get a remainder of 0. But notice that the remainders are starting to create a pattern, so we know the answer is going to be a repeating decimal. Looking up top, you can see that the answer is repeating in 27s, so the final answer is going to be 1.27 with a bar over the 27, letting people know that that pattern repeats forever. Now let's look at the situation where there's a decimal on the outside. When there's a decimal on the outside, you can't do the division. You have to first change the decimal to a whole number, and then you can do the long division. Let's look at this example. Let's set up the division. Okay, we have a problem. There's a decimal on the outside, and we need it to be a whole number on the outside. So what we do is we're going to shift that decimal point to the right until it becomes a whole number. We're going to have to shift it to the right one time. Now, whatever you do to the outside, you have to also do to the inside. So we're also going to shift the decimal point to the right one time on the inside. Now your new problem is going to be 5 going into 413.5. There's a whole number on the outside now. So now we can work out the division. Working out the division, you're going to end up with a remainder of 0. So the problem is done. And your final answer will be 82.7. Setting up the problem, we have an issue. There's a decimal on the outside, so we'll need to shift the decimal point to change it to a whole number. We'll need to shift it 3 times. Whatever we do to the outside, we need to also do to the inside, so we'll also shift it 3 times. Notice how there's a little gap there. If you see a gap, just fill it in with a 0. So now the new problem will become 9 going into 4,320. The whole number is on the outside. We can now do the division. Working out the division, you're going to end up with the remainder of 0. The problem is done. The answer is 480. Let's set up the problem. So once again, we have a decimal on the outside. We need to change it to a whole number. We'll need to shift the decimal point 2 places to the right. Whatever you do to the outside, you'll do to the inside. We'll also have to shift it 2 places to the right. So now the new problem will become 6 going into 15.8. It's a whole number on the outside. We can now move forward with the division. Working the long division, you don't end up with a remainder of 0. We'll add a 0, drop down, and keep going. We don't end up with the remainder of 0. We'll add another 0, drop it down, and keep going. Notice that the remainders are going to repeat forever. So this final answer will be a repeating decimal. Looking up top, you can see that the 3's are repeating. So the final answer is going to be 2.63 with a bar over the 3, letting us know that that digit repeats forever. Now that we're done, you can do something more useful with your time, like take a shower, because nobody wants you smelling like a trash can. That's not cool. Like and share. Math on the fly. Laters.